Hi, and welcome back to another video in BCIT's Technology Teacher Education Program. And this is going to be our first video in learning to use Fusion 360 to make printed circuit board designs. We're going to do something really simple called the Winky Blink circuit. It's a circuit that we've made before. I'm going to disappear from this window right here and turn off the video capture device so that we can come over here and focus on what we're going to be doing. Now, the Winky Blink itself is a circuit that we make with a lot of students, and I've talked about it on my channel before. And I've got this video on breadboarding the Winky Blink, which tells you about how to build it on a breadboard and how the circuit works. So if you want to catch that video, that'd be really good. And you can simulate it a number of different ways. In that video, I show you how to simulate it in Falstad Circuit Simulator, but people who've been in my classes before will know I'm a big fan of Tinkercad as well, also another Autodesk product. And what's kind of cool is that you can build the entire circuit in Tinkercad using their components and drag and drop it together onto a virtual breadboard. And then you can actually go send to, and you can send it over to Fusion 360. Now, does it work perfectly? Actually, it works really amazingly well in some ways, but it creates some pretty ugly schematics. So this is the schematic that it creates for you. And you can't tell what's going on in that circuit by looking at it. Technically, it's a correct schematic, but the whole point of a schematic is to communicate how the circuit works. So if you think of a schematic diagram as being like an essay, you can have an essay that's got all the right words in it, but if they're not linked together in a logical and coherent way, nobody's really going to be able to read and understand what you want. So I don't quite like how Tinkercad develops their schematics. I understand that it's really, really difficult to take a breadboard design and then figure out what the human would want as a schematic. Maybe that's something that AI tools will help out with in the future. But you can get all the components together. You can get a components parts list. And if you come back here and you send it to Fusion 360, you'll get all of your parts into Fusion 360. It's a neat way to get things into there. I'm not going to start that way though. I'm going to start with a just plain Fusion 360 because that way you can create any circuit without having to go through the Tinkercad entry point. Now, when you create a circuit in any circuit board design program or schematic capture program or whatever you want to call it, electronic CAD package, you're going to have a few different files. And here we have a project file, and the project file is holding our schematic. And here you can see the schematic in a little bit neater format. I've taken the time to put the schematic into a larger sheet with a title block on it and everything like that so we can print it out. But when we zoom in on it right here, there's your classic Winky Blink design. Uh, monostable multi-vibrator is the more the technical term. But anyway, we're going to be able to take a look at that later on, and we're going to create this schematic. I'm going to show you how to do that. Now, the next thing that we're going to do is we're going to take this, and every symbol on here is represented by a real world part. And you have to be a little bit careful about that because when I put this symbol in here for a transistor, there's many different transistors in many different packages out there. So some are surface mount devices, some are TO92 packages, which is what we're going to use. That's our classic in-shop transistor package. Some are TO220, which a lot of electronic students might know as looking like a 7805 voltage regulator. It's got 3 legs, but is a little bigger. We have to be careful about how we link these together with their board representative or their package, because when we come over here, we need to have various things coming together to match the transistors and the capacitors and the battery connections and everything that we're going to use. And finally, in our board design, we're going to put some holes into the board so that we can um, mount the board onto something. And then we'll try and design the board so that a student can actually manufacture it. And like one of the things I really like about the transistors on this board right here is that rather than having all 3 leads in a row, which is really easy to do, when you put this one back here, it gives you just that little bit more gap for soldering them. So if you're going to make this board and have your grade 8 solder it together, using this design of transistor is probably going to make it a little bit easier as well. This board that I've done, I could make it a little bit smaller and compact everything in. It would make it less expensive to produce with a group of grade 8s or grade 9 students, but maybe it's nice to have that little bit of extra space to give them something bigger to work with. Certainly, the smaller you can make it, the less expensive it's going to be because you'll be using less printed circuit board material and having to etch less copper off. All right, so this is a design that we could actually make using the toner transfer process. And this is the schematic that got us there. And the two files are joined together in a package. So I'm going to close them off right now. So if I close the package, everything just disappears. And I am sitting here in Fusion. So I'll get you to maybe if you've got a copy of the Winky Blink schematic around, you can set that on a desk in front of you. But it's really, really good to have a paper copy out before you begin. For my students, we've done it before. Anyone else, check out the other videos and you'll be able to copy the schematic down from there. All right, so you're in Fusion 360 and your electronics design is a little bit different from your mechanical designs because of course you've got this weird duality of a schematic that has to match the circuit board. Okay, so we're gonna go new electronics design right here. And poof, a window comes up and it says that you've got a new electronics design. And it says, start with a schematic. It's almost like it was trying to help you. So click on New Schematic right here, and this window pops up right here. And you can see this looks a lot different from your mechanical design library. Now let's just take a minute to go over top of what we're looking at here. The switch lets you switch between the schematic view and the printed circuit board view. You can change your grid settings, which layers you're going to display. As you'll find, we've got a whole bunch of different layers going on here. You can edit things, place things, connect. We're not going to talk about the simulate thing. When you design a circuit, if you've used parts that have mathematical models for those parts, you can actually simulate it to test and see how it's going to work. Fairly advanced feature that you probably won't be doing a lot of with your high school classes. Um, and then you can modify and change components. Now over on this side, it's got place components popped up. So if that didn't pop up, these might be up against the wall and you can kind of click on here to bring this out. And you'll see it makes reference to all libraries. These are your part libraries. Now keep in mind there's like millions of parts, electronic parts out in the world. And some of those parts will have the same schematic symbol, but different physical bodies. So for instance, I'll just pull something up right here. Here's a MOSFET. Okay, so it's a type of transistor and it comes in either a surface mount package, a TO220 package, or a TO92 package right here. So they're all the same part, they're all the same silicon, they're all the same symbol, but they're packaged differently. And depending on what package you choose, that's what's going to show up on your printed circuit board. So if you're making a bajillion of these for commercial products, you'd use a surface mount part for rapid assembly. But if you were just making one in the shop, you might use a TO92 if it handled low power because it's a smaller, less expensive part, or you might use a TO220 part because it's got that big heat sink on the back of it. So anyway, this is where we're going to pull parts out of our library and put them into our schematic design. Let's see, what else do you need to know on here? Well, that's probably good enough for now. We've got our project going here, okay, and we've got our schematic coming up here. Let's start by saving this, okay, and new design, um, save, there we go. Now, it's going to ask you what folder do you want to save this in or what location on your computer. So if you click the little down arrow right there, you'll see you'll have different projects going on. And since this is our very first project in making circuit boards, why don't you go New Project and just call it Circuit Boards. Okay, you might even call it circuit boards 2025. I'm adding the 2025 because Fusion changes a little bit every year, and I sometimes have to redo these videos. And I am going to now make sure that I put this into my circuit boards 2025. So my location is circuit boards 2025, and I am going to call this the Winky Blink 2025 JB. Put your name on there or something like that, so when it comes time to hand it in, it's already marked in there nicely. Okay, and you'll notice up at the top, my project name has changed and my schematic name has changed. Alrighty, now we're going to have to place some components from the libraries, and you probably have different libraries activated than I do. This is kind of just like when you're doing computer programming or working with the Arduino IDE. You've got a library manager. You have to go out and you have to get the software that you need to manage your library. So let's take a look right here. And here is the libraries manager. And I've downloaded a few libraries, added some. I've got 892 libraries active. Now, some of the libraries that I like to have active are Adafruit's library, okay? So if you want to find Adafruit's library, they're a manufacturer of some cool electronic parts, just go Adafruit, okay? And you'll find the Adafruit library in here. And by switching it from not in use to in use, you can add this library to something that's going to be readily available to you. You don't get to search all of the libraries when you're out there. In fact, you don't want to because there's many libraries, and you just want to have some that are really useful. So I've got Adafruit turned on. Um, I turned on audio devices. The little blue recycle logo there means that there's a newer version of this available. We might use audio devices later on. I've got the battery library available, the battery holder library. Those are all good. C-trim, this is for some little capacitors that I used in a project somewhere. The capacitor library is a good one to have on. You probably don't need circuit protection library turned on. Um, the Molex, that's for like pins and headers and all that. Probably not a bad one to have available on a pretty regular basis. Connectors, diodes, different displays. I've done a lot of projects on here, so I've got a lot of various libraries turned on. The one that I'm going to get you to turn on, make sure you've got turned on today, is Tinkercad. Okay, because we were talking about Tinkercad. So type in Tinkercad into Library Manager. When that comes up, make sure you've got the Tinkercad library in use. Okay, and then I'm also going to make sure that you have the transistor library turned on. And so Tinkercad is turned on, and transistor, the Fusion Electronics version of the transistor library is turned on. We can probably even turn on transistor NPN and transistor PNP on there. Okay, that should get us going as far as having libraries available to us to put parts into our project. Alrighty, so now let's start by adding a battery. And just to keep things simple, I'm going to come in here and I am going to use we just turned it on. I want to use the Tinkercad library. QRS. So I'm just using my center mouse button to scroll down on this list on this side. So over here, you should see it saying place components up at the top. Instead of all libraries, I'm just going to come down to Tinkercad. So I see just a subset of things going on. And you can see the Tinkercad library is still huge. It's got a whole bunch of stuff going on in here. But here's one to start with. Okay, battery 9V. Now, when I click on a component, you can see that it's got its schematic symbol pop up here and what it's going to look like on the breadboard, its footprint coming in right here. So it's not actually going to put a battery on your board. It's going to put the battery leads onto your printed circuit board. So now I'm just going to click on here and sometimes you have different things that you can choose from. This is only one right here. And I am going to just drag that in right here. And now you can see I'm going to put battery 9-volt generic. I can put it wherever I want. I can do a couple things to it. I'm moving it around right now. If I right click on it, I can rotate it around. You can see I've also got rotate commands and mirror commands right up here. I can drag this little window out of the way if I want. I'm going to put that battery right about there on my screen. And then I'm going to click done because I don't want 2 batteries in. If I wanted more batteries, I could just keep clicking in there. Okay, so that's out of the battery 9V out of the Tinkercad library. All right, now it came with a name on here, and that's a big, long, ugly name. And it also came with a part number. So you know how we've got R1 and R2 representing resistors? This one came in and it called itself U1, the first user component on here. I can pick that up and I can move it around, okay? And I can put it somewhere where it's easier to read. Remember, one of the things about making a schematic is making it easy for someone to read. And I can take this battery 9-volt generic. In fact, I don't need all that on there. So if I put my mouse over top of the battery so it highlights, I can click on there. I can go properties, and oh, that's supposed to be editable right in here. All you have to do is, I'd press pause there. I always have to stop back here and make sure it started recording again on my other screen here. Yes, I am recording. Okay, so all you have to do is right click on here and go to value, and it'll say it has no user-defined default value, but I wanted to change it anyway. And let's just change that to 9V. And then we should be able to pick that up. I had to hit the escape key to get out of that redefine, and there we go. It says 9V. If you want to get really fussy and bring that in nice and neat, you can zoom in or zoom out with your center mouse wheel. And by holding down the Alt key lets you do fine adjustments on your grid right there. Okay, so we've got a battery in there. It looks pretty good. Nice. Okay, the next thing we're going to look for in here is a switch, because we'd like to be able to turn this on and off. This has a momentary switch. Let's see. Oh, that's a push button switch. The Winky Blink would only work when we've got it turned on. You can see that that's kind of looks like a spring-loaded switch there. We've seen these things before. We don't want a tilt switch. I think it's in here under slide. My apologies, I just had to look that up. The names are a little bit weird sometimes. This switch that we want is actually listed as a toggle, and it's in the Tinkercad library. And when we take a look right there, you can see that the footprint and this looks like a part that we have available in the shop, and the footprint spacing should be 100 thou right across there, 2.54 millimeters. So our footprint should be good. So I can drag this switch in here and I can rotate that around. Using my center mouse button, I can drag my screen so that I can align this somewhere right here. And I can say I'm done. Okay, now I don't need to say that's going to be a toggle switch. In fact, it's going to be a slide switch. So on here, I can just click on toggle and press the delete key. And that's gone. I can move S1 up there. Makes it a little bit easier to read. And now I can come up here and I can click net. Now net is the name for what joins all of this together. And we like to keep our nets nice and neat and tidy. Try not to crisscross them too much, and try to keep them in nice straight square, easy to read lines. So when I've got a net connected in there, I've got my first 2 parts in here. Great, let's add a resistor. In fact, we're going to add 4 resistors. So I come back over to this side of the screen. I've got the Tinkercad library on, and I go resist. And here is the resistor. Now, for a resistor, I've got many, many, many different choices of components. So I click on the little drop down arrow next to resistor. And if you come down here, you can see that they're listed by different lengths, the 10.16 millimeter, the 11.7 millimeter length, the 7.2, and then I've got all of the surface mount variants and anyway, all sorts of interesting stuff. You can get away with a 7.2 millimeter long resistor. The little quarter watt resistors that we use are about 7 millimeters long. So if you bend the corners really tightly, a 7.2 would work. But I find if you leave yourself a little bit more room, the 10.16 works really well. So I'm just going to click on that, and you can see that I've got axial down here, 10.16 millimeter pitch. I'm reading this along the bottom, and I want 4 of these resistors. So I'm going to drag that in, and I'm going to put, let's go R1, R2, and I'm going to make these two ends, I'm not going to make them touch. If I touch, they'd be joined together. I want to show you how to join them together and have some control over that. Okay, and I'm going to click done. So those are the 4 resistors that are going to be in my circuit. And we can tidy them up a little bit. Take the part number, and generally I don't do the part numbers until I'm all done this circuit, but if I leave it until then, people never go back and tidy them all up. So put them in a place where it's easy to read right next to the part. If you decide to change something in your circuit later on, you can come back and change them around later on, but keep them nice and easy to read for people. Now these resistors all have different values, so if I right click on there and go to value, I can give it a new value. And this one right here is going to be about 470 ohms. This is just controlling the current flow to the resistor or to the LED. So I'm going to go 470, and I'm just going to say R because it's really hard to find the ohms key on the keyboard. It can be done. And there I've got 470R. It complained to me because I still thinks I'm doing the value function. I can't change a value on there. Tuck that in neatly on there. And then on here, I'll go to value and 470R. Okay, here I'll do that as well. Now down at the bottom, depending on how fast you want your LEDs to blink, you could use a lot of different values in here. If you wanted them to blink really fast, you could put in like a 22K ohm resistor. Our standard value is somewhere around 47K or 56K. So I'll make this one 47K for 47,000 ohms. Okay, and on here I'll go value, and I'll make this one 56K so they don't blink at the same speed. Like I say, yeah, this is just controlling the blinking. And so long as you're somewhere in that tens of thousands of ohms range, you should be fine. Now I'm just going to tidy all this up. When I go to pick up the part I want to move, I do have to click on that little crosshair right in the middle. You see there's a crosshair right there? And I have to hit escape to get out of the last command. So escape is a really handy key, and finding those little crosshairs. And then remember that holding down the Alt key lets you get it in there nice and tidy and aligned. All right, there we go. We've got 4 resistors in there, and now we're going to create a net to join them all together. And that net is going to come from the side of the one side of the switch or the other. The switch can be switched back and forth. I'll take it from here, seeing as how that shows the side of the switch that is not normally open. I'll drag it along to here. I'll click. Just a minute. I should have got a nice little bing sound when that connected right in there. Let's do another net and see if that happens. Okay, I guess it's not binging at me. A couple of things to note is that you see that there's a dot that's formed right there indicating those two lines are joined. If they crossed without the dot, they wouldn't be joined. The other thing I'm just going to try doing is I'm going to come up here to the move command. I'm going to click on move, and I'm just going to try moving this, and you can see that now that net moves with the resistor. Okay, now the nets are pretty important, and they're going to show up a lot because each net is kind of like the copper path that needs to be continuous between the switch and these two resistors. Over on your Explorer side right here, you've got the inspector, but you've also got a design manager in your tab. And in your design manager, right now I'm viewing the components. And you can see in the middle here, I've got a list of components, and I can click on R2 or R1 and it comes up. But I can also tell it to give me a list of the nets that are on my board. And in the various nets, if I click on net class right there, I've got I've got one named N1 and one named N2. So I can also pick up those nets from right in here. Later on, when it comes time to routing our board, you'll see that the nets have names. So you can take a look at the name on the net right there and see what it is supposed to be connecting by coming back to your schematic. Uh, we've also got layers on here. Talk about the layers later on. Right now, everything's coming in on the right layer. Let's come back to place components. Okay, it's time to add some more components. In Tinkercad, Tinkercad has a little LED component, and we want LED radial right here. And there's a picture of your device. This one's really cool because in it you've got, in addition to the symbol, you've got the footprint, and you've got a 3D model of it right here. And so later on, we can actually create a 3D model of this board, and this part will be right in here. That's really good because when you create the 3D model of your board, you can send it over to the mechanical side of Fusion 360 and design parts around it. All right, let's bring an LED in right here. Okay, and we're just going to put it out here somewhere. Yeah, let's do this one first so that we get it a little bit parallel. There we go. I'm not worried right now about the fact that the text is over top of there. Um, somewhere right in there. Try to keep this nice and parallel and kind of like a mirrored image of it right over here. There we go. We've got D1 and D2 in there. Now, to get rid of that, hit escape so that you're no longer inserting them. And then let's tidy this up a little bit. Let's just pick that D1 up, put it over there, and then right click on there and go to value. And we don't want it saying LED orange. We just might want 5 millimeter LED. Let's see if there's room for that. We can always just cut it down to 5 millimeter. In fact, we can get rid of that if we want it. People should be able to know. Now I'm having a hard time picking it up. When you hear it go bling bling like that, it's because I wasn't. Oh, no, it's because it still thinks I'm in value mode. I had to hit escape. And now I should be able to come in here. Get that 56K is getting picked up right there. That's where I wanted it. 5 millimeter LED. I left that a little bit long, so I'm just going to come in here and go properties. Just change that down to 5 millimeter. Or you could call it red if you really wanted to say that it had to be a red LED. You could put information in there next to it. Let's change this one. Value. Okay. And remember to hit escape when you're done, otherwise it'll make those horrible boing sounds at you. Let's play around with this to use the Alt key to get things aligned a little more neatly in here. And that's just click and drag with your mouse with the Alt key held down. Now we can add another net. And so I'm just going to connect that net right there. That net. Okay, so we've got the top half of our board done reasonably well. Let's take a look at the next thing that we're going to do on our board. That would either be the capacitors or the transistors. And in either case, things are going to start to get interesting. So let's go for the transistor. Now let's do the capacitor first because we're still in the Tinkercad library for that. Anyway, we'll talk about transistors in a minute. Capacitor. In the Tinkercad library, you'll see capacitor POL. And you'll see that there's different packages available over here when you click the down drop. And some of them are surface mount. And what's really cool when you come in here, you can see that you've got radial capacitors. Um, you've got surface mount capacitors. Strangely, there's no, oh, there's an axial capacitor. So the axial capacitor is one that lies flat across the board. Now, these capacitors are actually really kind of cool, these axial capacitors, because they, when you put them onto the board, um, when you put the axial capacitors on the board, you can route things underneath them really easily. And in fact, even if you were to go with an 11 millimeter diameter um, capacitor, radial capacitor, there'd be room to route a signal in between those legs. But really, we tend to use the 5 millimeter diameter, the small capacitors. And so we're going to take radial dash 5 millimeters as our part. And just select that and make sure that's what it looks like down at the bottom of your screen and drag this onto the board right here. Not particularly fond of the schematic symbol of it. I kind of like my classic curved negative side, whereas this one just gives you a black negative side. And remember that these two have to be pointing in opposite directions. So I'm just going to do, I right clicked twice to rotate this here. So one's pointing out that way, one's pointing out this way. Then I'm going to click done. And seeing as how I'm still working in the Tinkercad library, before I get to the transistors, I'm going to add a diode in here. And there's a diode right here. You can see other cool parts. There's our diode right there. So we can see that our footprint is what we like, the symbol's what we like. We're going to drag that in. I'm going to put it right here. Okay. And now it's time to clean some of this up a little bit. So right click on the diode, go value. I'm going to change it anyway. I'm just going to get rid of anything on there. Technically, you could say like 2N 2002 or something like that, but I'm just going to leave it blank. It's a standard rectifier diode. And move that, put it right in there next to there. And for C1, I'm going to right click on there. I'm going to go value. And this is going to be about a 10 U or 10 microfarad capacitor. And you see that pops out in the bottom. So I'll just hit escape so that I can get some different commands in here and then click on the 10U and using the Alt key, line it up nicely in there. And for C2, sorry, that was properties that I went to, cancel that. I click on C2 and I'm going to go to value and 10U will be fine. Again, these values you can play with depending on how fast you want your LEDs to blink. Of course, I put it up top where I didn't want it to go. I want it to come down here, hit escape so that I can select things again. Don't pick on the, there we go. Align that in there nicely. Okay, well, this is coming along great. We've got everything in here and we've got them all out of the Tinkercad library. But now we're going to have to go and find a part that's a little more fussy. One of the problems with the Tinkercad library is that if you look for a transistor in it, you've got the 4N35, which only comes in a chip. You've got the phototransistor, you've got the TIP 120. If I look for an NPN transistor, which is another thing to look for, so sometimes they don't always say transistor, they just say NPN. You've got various variants of it down here, but the only ones that they've got go collector base emitter. Whereas our transistors, as you'll recall, are the 2N3904s that go emitter, base, collector. So, and if you're watching this on YouTube and you're not from my shop, go take a look at the transistors that you have and make sure you use the transistors that you have in your shop, because any NPN transistor will do. But if you're one of my students, we are going to use the 2N3904 transistor, which is an emitter, base, collector transistor when you look at it from the front. And the Tinkercad library doesn't have one. So now we've got to come back here. And in this menu, we're going to tell it that we're going to look in all of our libraries. And in all of our libraries, you can search for NPN. And you'll see that you've got a whole bunch of choices coming up. You could try searching for 3904. And you'd click on that and you'd say, perfect, 2N3904, I found my part. Except I've done that already, and I know that they didn't build the 2N3904 part correctly. And, although it's a great example of why you always need to check your components when they're actually on the board, they made their 2N3904 a collector base emitter version. What we actually want is NPN underscore right here. And nope, that's not it because it's not letting me choose the thing. In all of your libraries, if you search for BC546, okay, we don't want that one. We want this one that says NPN underscore TO92 BC546. And this says it's collector base emitter, but when we put it in, I'll show you, it's not. I just, anyway, somebody else made up the libraries. Later on, I'm going to show you how to make your own parts in your own library. And then if they don't work, you've got no one to blame but yourself. Okay, so we're going to put Q1. It's going to say BC546, and that's going to line up right about there somewhere. Right there. Now I'm going to take it over this side, but just to keep my schematic neat and tidy, you can see that I've kind of been mirroring everything over on the other side. I'm just going to hit the mirror button right up here. And now you can see that I've mirrored the transistor. Now it's perfectly okay to mirror the transistor in your schematic, but be very careful when we get over to the board that you don't mirror the transistor. I'm warning you right now in case I forget you later. When you're on your printed circuit board, mirroring a part actually flips it from the top side of the board to the bottom side of the board. You do not want to mirror anything on the circuit board side, but it's okay in schematic. I'll just click here for done. Okay, so now we've got some transistors in here, and I'm just going to right click on this and I'm going to go to value, and it's not a BC546. We're going to use a 2N3904. And then we're going to say value 2N3904. All right, so now I've got these two transistors here. And as you know from our schematic, they are going to be connected with a net that joins their emitters together. I'm just going to put that net in about like so, neat and tidy. And I'm going to click done. And now what I've done is I've joined the two emitters together, and I want to make sure I've got the right part, because with the resistors, it doesn't matter if you get them wrong. Even the capacitors, if you connect them incorrectly in here, when you're assembling your circuit board, you can flip them around and put them in backwards. But your transistors, they've got three legs, and if you wire them up the wrong way, your board's not going to work very well. There's ways around it, but you don't want to do that. You want to make sure you got it right. So I'm going to make sure that my two emitters are connected together. And to do that, it's time to start looking at what this is going to look like on our actual printed circuit board. Okay, and to do that, there's this switch button in the top left corner of the screen, and I'm going to switch to the PCB document. There's going to be a little bit of a pause here while it generates it, and then this is all going to come together. And here's my printed circuit board. Here's all those parts or their footprints. And what I want to do is I want to come over here and pick up my Q2 and I want to move it over here. And so I'm looking down at the board from the top and I'm just confirming that I've connected my emitters together because on a 2N3904 they go emitter, base, and collector. Eat big cookie. Emitter, base, collector, emitter, base, collector. I've got my emitters connected together when I look at this from the top. I'm happy with that. I'm not going to do anything else over here. I'm just showing you what this is going to look like when we bring it over to a board. And so let's come back and let's finish up our schematic because we know we've got the right part here. Okay, in our schematic, the diode comes down here because the transistor turns the diode on and off. That happens on both sides. And the 56K resistor comes down here and connects to the base, or you could use a 47K resistor and it comes to the base. And then we come over here and, oh, does the positive side connect to the collector or does it connect to the base? I just had that all worked out today. This is why I should have a schematic in front of me while I'm looking at it. It comes over here and it connects to the collector. I'm going to pause the video and go check that. Yeah, I'm glad I checked that. It does come to the collector here. And that means that this side right here, the negative side is going to come over here to the base. And make sure your positive side comes over to the collector. And the cathode side, negative side, goes down there to the base. Excellent. This is starting to look like a Winky Blink circuit right here. And because we've been keeping it neat and tidy as we've gone along, it's coming together nicely. A couple of nets right in here. And we should be finished the circuit. Now, take a moment to take a careful look and make sure your schematic is correct. Because when we go to design the board, we're going to follow the instructions and the layout that's on right here to create your board. If there's a problem here, you are going to make that problem permanent by building it onto your printed circuit board. Okay, if that all looks good, then we're doing all right. There is a way, before we leave this, there is a way to make this look quite nice. And what we can do is we can go to place and we can insert a design block. And cancel that. Don't do that. Yeah, sorry about that. That was the wrong thing to do. We're actually going to insert a title block using the exact same commands that we've been using all along. Let's just go to your library manager here for a moment. So library manager, that little thing right next to where it says all libraries. And just look for the library called frames. And there's one here from Fusion Electronics. Make sure frames is turned on. Okay, it's got a whole bunch of sheet layout things. And so if we turn that frames on, then when you come in here and search for a part to place, okay, and you go frame, okay, there's a whole bunch of ones that come up right in here, but we tend to print on A4 paper, okay, and there's one with the title block up at the top. Let's see, A4, small dot field. There we go, A4. That's a landscape one. There's your portrait one. A4, L for landscape with location and document field. Drag that in right here. Zoom out a little bit. Come back in here. Place that and click done. And now when you go to print that out, that title is already placed on there. and it says not saved. If I click save, it should update, and it should have the timestamp on there. And the last thing that we'll have to add is your name to it. So you can come over here and under design, under document here. So along the top, come to the document tab, click on text, and I'm going to put this text window out of my way so I can see what I'm doing here. Oh, found a new home right there. I think I want that a little bit bigger than 0.07. Let's go to 0.1 and see how that looks. Use that Alt to line it up a little bit nicer. There you go. And now you've got a title block with the title of the drawing. And of course, something's changed, so it says not saved now, but that'll update when you save it. And now when you go to print that out, you'll have a nice title block for your diagram. Okay, let's hit save because that's all looking pretty good. On to building the printed circuit board. So you should have these tabs open. If you didn't do that earlier, you can just hit switch and go to the PCB document, but you probably already have a tab open up there. All right, now the neat thing about the printed circuit, about the Winky Blink library, or the Winky Blink project, is it fits onto a pretty small circuit board. This is currently the boundary of our board, this dark space in the middle. I'm just going to click on that window and drag it in, keep everything nice and parallel. Again, drag this down a little bit. We don't want any rhomboid boards. I'm just going to give myself a little smaller space so I can zoom in and see what I'm doing here. All right, now if I go over top of a part, I can highlight it and I can move it around. Now these yellow lines are going to be really frustrating to you when you get started out. The yellow lines are called air wires, and what they're indicating is the net that you're dealing with. So I'm just going to take this 9-volt battery, for instance, and put it right in this corner of the board. Okay, that's going to make it easy to run some wires to that and get out there. In fact, I'm going to move it in just a little bit in case I want to put a little hole for strain relief next to it. Okay, so for instance, let's take that diode right here. And now you can see the yellow wire on that diode. One of them is getting shorter as it comes right in here. And there we go. That's right in there. And then the other side is connected to this transistor over here. But that's all jumping around, and you can see that there's one line that jumps back and forth because if I bring that in really close here, it's just showing you the closest distance to get on there. Now let's zoom in a little bit. I want my emitter to have a nice straight run to the diode. So I might put my transistor in this orientation and then take this transistor down and also put it in that orientation. Now up top, I've got a switch, and I did 2 right clicks on the switch to make it come around. You can make the switch go in kind of any way you want. You could have the switch up and down like that if you wanted. If I was going to do it this way, I'd probably put it this way so that when you slide the switch into the up position, your circuit comes on, because up usually means on. Now I'm not cleaning up all my text right now because we're going to move these things around a lot as we come to sort things out. And so we'll tidy up all the text and add some features at the end. R1's going to come along the top right here. Okay, and I tend to follow what I've done on the circuit board. R2 is going to come in here somewhere. And as you can see, I'm trying to clean up my air wires so that they have a nice, fairly straight run to them. I might need a little bit more space down here. We'll see. Let's bring in R3 and R4. Now you see that's not aligning nicely for me. That's a good case for holding down Alt while you try to move it around. Oh, it's trying to avoid the transistor. So it has some smart features. It doesn't want to get in the way of the transistor. Get that transistor out of the way. Actually, Alt lets me line it up nicely right there. R4. I don't necessarily want them overlapping like that, but I do want them in nice and close. So zooming in with that center mouse button lets me get things in there pretty neat and tidy. Might need some more height on the board. I'll give up some width in return. Bring this down here for now. Bring that down here for now and get things spread out on there. So basically we're following the layout of the printed circuit board for getting these aligned on here. D1, when I bring it in, you can see that D1 is probably going to be easier to place on this side of the circuit than on that side of the circuit. And I can rotate it around. It probably doesn't make much sense to put it in this way because you can see that I've got crossing air wires. And if I put it in that way, the wires don't cross. Oh, there's one of the capacitors. Might put that right there. I was actually looking for the other diode. And you can see that the diode, although the flat side isn't quite as prominently marked on there as I'd like, it is marked. And I'm just going to bring that down. So I kind of align that with that right there. Now, when I click on this, you can see it gives me a position 1450 by 600. And when I click on here, it gives me 450 by 600. So these are 1,000 1,000ths or 1 inch apart, horizontally 450 to 1450, and they are 600 thou or 600 mil off the bottom of the board right there. So they're both at the same height. They're pretty nicely spaced on the board. Let's finish up with this capacitor right on here. And as you know from maybe having built one of these by hand earlier on, how you place the components is pretty critical to how things come out on the board. And I've built this circuit quite a few times, so I'm giving you a pretty good layout to start with. In the future, I'm going to let you figure out your layout. But for now, we've got these laid out on the board pretty nicely, and we can start thinking about how we might connect them together. Okay. Now, I'm just going to press pause on here for a little bit and let you take a look at it and see how you might connect some of them together. I'll connect the easy ones for you. So from the diode to right here, I'm going to click right there. Now, there's a couple things going on. First of all, you'll notice it's really skinny and that it's really red. Okay, so you see that wire? That's net 10 that's coming in there. And I don't want it to be skinny and I don't want it to be red. So I'm going to have to make a few changes before I go and connect them all up. Okay, the first change I'm going to do is I am going to change my rules for the board. So up here, if I click on rules, I've got a whole bunch of rules that I can tell the board that it has to follow. Now, the default set of rules are great if you're sending the board out to have an industrial site manufacture it. But in the shop, we can't follow all of those design rules. So come to design rules right here. So it's under the rules menu up at the top and then the rules button. And you will get this window popping up right here. And there are a lot of rules for how your board can come together. So your wire-to-wire clearance is the minimum clearance between any two pieces of copper on your board. And we can usually get away with going down to 10 thousandths of an inch, but if we tell it we want it to be 15 thousandths of an inch as a minimum, then you're less likely to have parts touch each other. Same thing with wire to pad clearance. So it's got this little diagram right here where you've got a pad, that you're drilling a hole through, and then you've got your wire or your copper net running right there. Again, let's make sure we do 15 as a minimum spacing. You could say 20. The more space you give yourself, the more space you'll have for grade 8 students or grade 9 students learning to solder to make a small mistake. We're not going to use vias, so we don't worry about them too much. Pad to pad clearance, let's make sure that our pad to pads are a minimum of 20 mil apart so that when students solder, oh, sorry, I clicked OK. What I should have done is just kept on changing things. So again, that's rules, rules, design rules. Come back in here, we change the wire clearance and the pad clearance to 15, the pad to pad clearance to 20. I'm not worried about pad to via clearance because vias are on 2-layer boards. This is going to be a single-sided board. SMD is for surface mount devices. We're not using them. Board outline clearance is how far away from the edge of the board you are. So that's fine right there. We're not using a copper restrict or via restrict layer or solder mask silk screen on this. Drill clearance we don't have to worry about. Um, where are we down here? Our copper width. So that's the minimum width of any copper object on the board. And we want to take that up at least 15, but I like to do 20 because if you're etching your own board, that just is so much nicer. Okay, so there we go, 20 right on there. Minimum drill size, probably not going to be an issue. Everything else on here looks good. So under your design rules, wire to wire clearance, 15 mil for doing it ourselves. Wire to pad clearance, 15 mil for doing it ourselves. Come down here, pad to pad clearance will go 20 so that when students are soldering it, they don't get things jammed up. And then copper width, we'll set that to a minimum of 20. And we'll click OK now. So now that we've set the design rules in here, we'll come back to our design tab up at the top, get us all these menus right here. And then we'll come along here and we can click on the rope manual button. And when you go like that, now you can see that it's a much thicker line, but it's still red. So hit escape to get out of there. Or sorry, you can start routing it. Hit the space bar and you can see that that's a via. We don't want that. We're doing a two-sided board, so don't just hit escape and hit the space bar and now start routing. And that space bar flips you from one layer to the next. And you can see now I've got a blue line and that blue line is coming together right in there. Okay, and so the blue line goes down there and that connects those two together. Now, you may be wondering a little bit about what you're seeing right here. Let's go over here to the layers and here we've got the layer sets that are on. If you saw anything in red, that was on your top layer. Anything on blue is on the bottom layer. So think about your monitor as being the printed circuit board. The top would be on the screen facing you, and the bottom would be on the back of the monitor. And technically, you wouldn't be able to see that. The computer kind of gives us an X-ray vision that lets us look through all of the layers at the same time. And we're putting all of our copper on the back because our components are going to go on the top. So we'll look at this from the top. Later on, we'll get into using two-sided boards and we will put things on the top layer and we will have vias that go through the board to connect them. Okay. Um, there's also names layers and that, so names and values and little eyeballs next to them. So you can turn off various layers. And if I turn off the values, you can see that I lose all of those values there. There are also layer sets. So if I want to see what this board looks like from the top, I can come in here and tell it, give me preset, there we go, preset top. And this is what we'd see if we were just looking at the top of a two-sided board. Of course, on a single-sided board, we wouldn't see the pads at the top because we wouldn't have copper on the top. And if we were just looking at the bottom, well, you'd see the pads and you'd see the connections joining them. But we're going to set it back to preset standard, and we've got our X-ray vision through the board. So that's what we're looking at right there. Let's get back to routing. Positive side of our battery is going to come in here. We get that nice little bing reward sound. And you can see this is all net 2 coming together right in there. Now down here, I like to take this and bring it out and join it together right like so. I tend to like nice, clean, crisp, square lines. Makes it easier to follow the lines and figure out what's going on the board. So for instance, down here, rather than just joining it like that, I might come down to here and then join it like that. Doing this also keeps that copper away from any other traces so that if there's a problem that you have to fix later on, you'll stand a chance of doing it. Okay, now as we've got those coming together, um, I'm going to pause here for a moment. I'm going to see how you do at joining the rest of them together. Well, I've been having some fun joining them together. And now I've got into a situation something like this, and you might be in a similar situation right here where, hey, how do I go from there to there? Because I can't cross this. Like if I try to route something through here, you see it just pushes that back. If I try to route it through there, it pushes that back. Well, sometimes you have to find alternative routes. And that's where having these nice big long flat resistors comes in handy because I can come around over here and finish my routing by scooting out and going underneath the resistor. And you might recall doing that when we designed the circuit boards by hand. So now I've got it all laid out about like this. And I'm going to come over here and remember when I was on rules, I went to rules right here and I can go check design rules. And when I'm all done, it comes up here and it says no errors. And that no errors is really happy. So technically I'm almost done right now, but I'm going to clean up the board a little bit. And I'm going to uh, put my component numbers into a little bit easier to read space here. So let's come back to design. And let's think about the person who's designing this. We want to make it as easy as possible for them to put everything in the right place. So I'm going to hit escape to get out of whatever I was doing before. And I'm just going to put D3 next to the diode and D1 next to the LED. U1 over here. Now for the battery, I might also want to say, that's got a value. I'm going to say yes. Okay, 9 volt. Oh, I want to show that properties. Oh, I wanted to show it, but anyway, I'll worry about that later on. There is a way to get it to show that value so that we can say that it's a 9 volt battery. Switch 1, let me hit escape. Keeps giving me that annoying bling. I'm going to put right there. R2. Very important that you know where R2 is, at least if you ask Darth Vader. It's the plot of the whole first Star Wars movie. R3 is not so important. Now, I'm not worried about putting this over top of the copper line right here, because remember that the text that we're moving around here, just like these outlines right here, they're all on the top layers, okay? The copper is down on the bottom layer. So technically, if you're looking at this on a printed circuit board, you'll see holes and you'll see outlines, you'll see part numbers, but you won't necessarily, well, you absolutely won't see the copper lines right there because they're on the other side of the board. So D2 can come out over here, Q2, sit right there, Q1, let's see, C1, C2. Sometimes, like if you've got these two close together, makes sense to put the numbers on opposite sides. And there we go, we've got some part numbers in there. Now I said we might want some mounting holes to hold this all together. And that's where under the design thing, you've got this place, and I can click right there. And it's going to let me place a non-plated through hole, or NPTH, right there. And that came out really tiny. I didn't want to do that. Control Z is a great tool. Undo that. I'm going to go place a non-plated through hole, and I'm going to tell it what size drill I want it to use. It's not big enough for what I want. I want to make sure that this is at least 1/8 of an inch, or 125 thou, so that I can fit a screw there as a mounting hole. I'm going to make it like 140 thou. It's just making sure that we have place on the board to run a screw through, and this should hold like a number 6 screw or a number 8 screw. Okay, that's pretty good on there. Now, the other thing I need to add to this is some information about what it is. So I'm going to come to Document, and under Document, you can see that I've got some draw commands, and in there I've got a text command. So I'm going to put my name on this. Okay, and I'm going to make sure that the size, you know, a little bigger than 70. I'm going to go 86 thou. And where do I want to put my name in here so that it's visible? So long as it's not touching any copper, you should be fine. There we go. I've got my name on there. And then we should have the name of the board, Winky Blink 2025. Now, I don't see any places where I left that to go in horizontally, so maybe I can rotate that and slip that in vertically right about there. Okay, and nicer if everything's perfectly horizontal. But on the back side of the board, some of that titling, it's more important that you get it in there than that it's all the same size. Okay, so that's looking pretty good. I'm going to hit escape out of there. Now you'll be wondering, okay, why does that show up as mirrored? Remember that if you're to get up out of your chair and walk around to the back of the board, you'd actually be looking at the copper from that side of your board. Okay, or hold up a piece of paper. You'll remember doing that when we were making these by hand and drawing things on the back, that things got mirrored when they were on the back side of the board. Um, so there, that's really good. That's going to appear on the back of the board right now. You'll notice that I've left lots of space in case, you know, solder splops anywhere, so grade 8s don't make mistakes. The board's still a little bit big. I'm going to tidy it up and shrink it down a little bit here. Well, there we go. That board's a little tighter, a little neater, doesn't take up quite so much space. Still playing around with things to get them into really nice locations here. A little bit of symmetry and parallel works out really nice. But there we go. I got a couple of mounting holes in there. I've got my part numbers all showing in here. If we come to the layers level, I can tell it that I want to take a look at preset top. And this is what I'd show my students as far as assembling the board and how it should go together. If I was going to print it, I'd go to preset bottom, and this is how I'd print my toner transfer to get that to come together, and that's what would go on the bottom of the board. And yeah, that's about it. I'll go back to preset standard. That's what I get when I look through the entire board. So I am going to hit save on that. Okay, there we go. I come over here. I've got my schematic. It's in a nice frame. It's got my name on it. It's got the title on there. It's all saved. Um, that's brilliant and it's ready to go. And this is saved onto my Fusion 360 cloud. So I am done this circuit. What I need to do is prepare something to submit and hand in. So what I'm going to do is I'm going to come to output and I am going to go print. And I am going to tell it that I want to print to PDF, print to file PDF right there. Okay, and it's going to be letter, landscape, scale. Now for your schematic, the scaling doesn't really matter. You can tell the schematic that it's okay to fit to page. Over here you've got some options. Don't mirror or rotate this in your schematic. Just tell it that you want it to be black, and you can get rid of the caption on there. And that's what it's going to come out looking like on your page. You can click OK. And somewhere a PDF file should show up. I didn't say left clicking. Anyway, that should have printed. Output, print, actual scaling. Oh, give it a browse to where you want it to save. So that got saved to some weird file on my desktop. So I'm just going to open that with Adobe Acrobat. And this is what it looks like in Adobe Acrobat. Brilliant. Okay, so now you've got a PDF of your schematic. Okay, I'm going to cancel that. And then I'm going to come over here. And this time, I'm going to print out the board just like this. Normally what you do is you'd print out your top layer and your bottom layer separately and use them as toner transfers. But because you're just doing this for submission and to show it to me, you're going to go output, print, again, print to a file, and make sure that you have solid turned on anytime you print this. And that should be good. Oh, scale factor must be 1 when you print this out. And always check before you do your toner transfer to make sure that you did get a scale of 1 to 1. Print that out. And oh yeah, it went to that weird file again. So if you just go print again, click on that folder, and that should have printed out to right here. Right click and open with Adobe Acrobat. There we go. And that's what that file is going to look like when it prints out. And I'll be able to take a look at that and see if that makes sense. First thing I check for is, do the emitters on the transistors go to the right side of the diode? Is the diode the right side? Is the battery the right side? The switch comes in here. I've got my resistors. Looks brilliant. Okay, so save those files and save this file, and you are done your first circuit board. And congratulations, we'll do something a little more tricky next time.